Well, hey there, I'm Shannon Kiebler, and I wanted to get you a quick little training on problem solving. It's probably one of the things I am the most asked about in terms of math instruction and how best to teach our students how to problem solve. It's a thing that people complain about the most, that is the hardest for our students. So let me deep dive into a few things that I think will really help you as you teach students how to do story problems. So again, my name is Shannon Kiebler. I'm a elementary math specialist. I work with schools, districts, teachers nationwide for elementary school, kindergarten through fifth grade to help them implement best teaching practices. So I'd love for you to connect with me online if you haven't already. There's all of these places you can see on the right to connect. And then if you happen to teach with the curriculum Math Expressions, make sure you're in our Math Expressions user group for Facebook, where we teach live every Monday night and lots of great supporting content. You do not have to teach with Math Expressions to do this training. This training is good for all curriculums, for all learners, language learners and not, right? So let's get started. First of all, you might recognize this poster. They are very popular on Pinterest and Teachers Pay Teachers. And maybe raise your little hand if you're thinking, I kind of use that strategy. So it's okay. There's no blame or shame in the game, but I'm going to suggest that we don't use cubes. And there's a few reasons why. So first of all, C.U.B.E.S is very solution oriented. It is about finding the answer and finding the answer quickly. Notice that in none of these steps is the focus on understanding. What is the problem about? So we spend so much time in reading talking about make a movie in your mind, know what you are reading about, the comprehension. We all recognize that comprehension is extremely important, if not the most important part of reading. Now, we also recognize there's some skills involved in reading, like phonemic awareness and phonics and sight words. Like we understand that there's components to that kids have to have in place in order for them to comprehend the story. Well, I don't want us to forget that it's very similar in math class. Our number one goal is that kids can comprehend and understand the problem. Our secondary ideas or goals are what are the skills they need in order to decode that text. So we're not saying that these are all bad things, like circling the numbers, underlining the question, boxing keywords. I'm not saying they're all terrible. I think there's some good merit to all of these different strategies. It's a matter of when we use them. And then, of course, how we use them. So when I introduce a problem, what you see on the right, Sarah's brother has 56 Pokemon cards. Each card was worth about 30 cents each. For his birthday, Sarah gave him 27 more cards. How many cards does he have now? And if I were to go through and follow all of these steps, you'd start to see that I could circle 3 different numbers. I could underline the question, how many does he have now? I could box keywords, how many, gave him. That's a keyword. Was worth, maybe not. Okay, so I have a couple of different keywords. Eliminate what we don't need. So I don't think I need, I don't know, I'm not sure because it never told me to even read the problem, but I think maybe I don't need to know how much they are, and then go ahead and solve the problem. But I'm solving the problem based on some of those keywords, right? And there's 2 different ones. So what if I'm a language learner and I see, well, it says Sarah gave him. Okay, so that doesn't mean when you give someone that maybe you are taking away. Or because if I gave away, like there's just so many things that can be taken here. How many can mean to add, but it can also mean that we had to subtract. It could also mean we had to multiply as we get into the upper grades. So the reality here is that C.U.B.E.S isn't terrible, but it is terrible to start with. So where would we put it and how might we use it? So let's talk about these keywords. So you can see there are 20 crayons, 10 crayons are in each box. How many boxes are in all? Now read that again. There are 20 crayons, 10 crayons are in each box. How many boxes are in all? So now my keywords are how many and then in all. That makes me think I'm adding. Those are the keywords, 20 plus 10. But as you read, you realize, wait a minute, this is a division problem. This is not an addition problem. So keywords fail us. Keywords are pretty sure thing in kindergarten and first grade, as everything is pretty straightforward. Add to, take from. But then as we get into second grade, we start to get more complex and on purpose in the standards, very difficult language, okay, for comparing and for all of our other operations. So it just doesn't outlast. It's not generalizable. We can't say these are always the words you're going to see when you add. Now, can I say we've noticed a pattern? We've noticed as we continue to work on these share equally problems that there's often shares or gives or all the different words that tend to keep popping up for us in all of these problems. Or we keep noticing each time or how many each. So we keep noticing that word each. So can words trigger pattern? For sure. We just need to represent them as a pattern, not a rule. So often we're noticing when we see this language, it would mean to add. But let me show you some examples when it doesn't mean to add. So that I don't get caught in this, I'm only reading the problem to look for keywords. That leads us to the condition I call lovingly solutionitis. And it's the idea that there's a condition in which a solution is given regardless of understanding. Solving is the main goal and often can be used to describe the disease of faster is smarter. Now, this is my own definition and a made-up word, but I really do think that kids have solutionitis. But why wouldn't they? That's what we've taught them. We've taught them to circle the numbers, to box the key words. Where in there have we said, hey, it's probably important that we understand the problem? We haven't. We said the solution is the most important part, so let's get there as fast as we can. That is perpetuated year after year after year. And the problem is the story problems get harder and harder and harder, and now students have no idea what's going on. So we're going to fix the solutionitis. So here's the problem-solving process. Now, this happens to be a process in curriculum math expressions, but every curriculum has something similar. So I want you to think about the curriculum that you might have and look at your steps and decide where you might modify some of the language or add in one of these steps, or you're like, oh, well, they're calling it this, but really it's this, okay? You can use it for any curriculum, for any problem-solving process, but just know that your curriculum probably also has one. So the first one is understand the situation. Second is represent the situation. Third, solve the problem. And 4, check for reasonableness. And what's important is that these can be done in any order. So it doesn't have to be, I first do this and then I do this. Now, I tend to start with understanding the situation. It's very helpful. But some students are literally just yelling at the answer. 81, the answer is 81. Okay, well, let's just put that. You solved the problem as 81. That's not the full concept. That's not exactly what I want you to do. I also want you to be able to tell me, what does 81 represent? How did you solve it? How did you know to put those numbers together with addition? Those are the types of things I want to dig deeper in. Another thing I hear is, well, why are there so many story problems? They just need to learn these other skills like the multiplying and the dividing. Make the main thing the main thing. There are many lessons where there's story problem after story problem after story problem. And first of all, I would argue because math is inside of our life, not outside. Well, I'm not going and doing random problems like in my free time just because I like doing math. I'm doing math every day because it happens organically in my life. So everything should be in context of a story problem. But secondly, there are times where I have lessons, we don't even solve the problems. I know, that's crazy. Because I want them to focus on the understanding of the problem, because guess what? That's the hard part. So whatever the hard part is for students, that's what we should be focusing on to help them get through that. The solving is often not the hard part. It's figuring out what to do with the numbers. That's the hard part. So let's go through this process and I'll show you how it all fits together, and then you can go and try it with your students. So I have this problem. There are 295 students. Each school bus holds 25 students. How many buses are needed to fit all of the students? So understand, the first thing I want you to do is read the problem out loud. The second thing I want you to do is I want you to read it at least 2 more times, a total of 3 times. Now, I tend to read the whole problem out loud with my students. Then I say, now everyone whisper read it to yourself. And I'm like loud whisper reading it so that if I have any students struggling with the reading, they can hear me as they're also whispering through it again. Then I say, now read it a 3rd time by yourself. And by the way, just so you know, when you're done reading it the 3rd time, I'm going to be taking it away. You will no longer be able to see it, but I will be asking you to tell me what the problem was about. You should watch kids. They're like, what? She's taking it away? And then they really start reading it. It's close reading. You care about what you read when you know you're going to be asked about what you read. So we read it those 3 times. Students indicate that they are finished reading. I take the problem away. I literally just go to the last slide, the next slide. I cover it up on the document camera. It's done. Understand, I want you to read the problem 3 times. I often find teachers will read the problem 1 time and they immediately start asking questions. Are you ready to start answering these questions with only reading it 1 time? How many of you caught yourself already rereading the problem? We all do it, right? I need to really think about the problem and read it through a couple of times before I'm ready to process any sort of a question. So rushing to the question, again, is indicating we have solutionitis. So now I say to friends, to understand we have those 3 reads. Now I want you to tell the story by acting it out with your hands. It doesn't matter if you're in kindergarten or you're in 6th grade. I've got these friends acting out with their hands, and guarantee you this is going to help your students who are really struggling and the students who are flying high that just happen to know, they see the pattern, we know we're multiplying, but they couldn't tell you why. Language learners, oh my gosh, earth-shattering. Try it. Okay, so here's what it would look like. No numbers, generally, no names. In fact, if kids are just jumping to solving, I will just take off the numbers. Okay, I cover them up. I put sticky notes over them. The numbers are irrelevant. It does not matter right now what the numbers are. I just need you to understand the problem. Okay, so I might say, who can start the story problem? And someone says, well, I think this was about buses. Okay, that's all they're able to say. I'm like, great, good start. Who can add on? Well, it's also about the students. And they're going on a field trip, and the buses can hold only a certain number of students. And then they have this many students, so they need to know like how many buses they're going to need. Oh, well, now tell me with your hands. Where are the buses? They're like, okay, well, here's the buses. Well, here's a bus. What else do you know? Well, there's kids. Show me the kids. Like, well, here's all the kids. Okay, here's all the kids. What are the kids doing? They're like, well, some of them, because if we don't know the number, some of them are getting on the bus. I'm like, okay, are there still kids left? They're, yeah, there's still kids left. What are they doing? They're like, well, they're getting on a different bus. Oh, so you have a number, and is it the same number that goes on all the buses? They're like, yeah, it said like they can only hold so many. Okay, so I have a bus. Some kids go on it. Then I have still some more kids. So more kids go on that. Some kids go on that bus. Then I still have some more kids. So really, we have a number, and what are we doing? And kids will say, oh, we're just sharing equally. My hands told the story, right? So if I said something like, I had some apples, show me the apples. What happened now? They're like, and then I ate one. Show me what would happen if I ate some. They're like, oh, I just take it away. Like, oh, what are you doing? They're like, oh, we're just a take from problem. Right. I had something and I'm taking from it. Okay, I have equal groups. There's 3 bags of apples. There's 4 apples in each bag. So there's 4 in this one. There's 4 in this one. There's 4 in this one. What is that? They're like, oh, it's equal groups. You start to see? Okay, so I'm acting this out so that they can understand the problem. So 295 students. Okay, show me the students, right? It says each school bus holds 25. So 25 here. Now what do we know? Well, then you have to do another 25. Now what do you know? Oh, you have to do another 25. Okay, great. So we know it shares equally. So understanding. We're going to build language through retelling. Once they told me the story, friends, turn to your neighbor, tell them the story again. And kids are like, oh, I'm not kidding. Just go do it again. And it's interesting how we could have told the story and there's still lots of kids that still can't retell the story because they're not used to me asking that. They're not used to having to listen and do something with it. They're used to the teacher walking them through the story problem, telling them what to circle, and then all they have to end up doing is adding over here. So this whole, I got to understand the problem is brand new to them. The more I do problems like this, the more they start to recognize I've got to be paying attention. And when I actually act out the problem, it's helping me to know what to do in the problem. So what do we know? What do we not know? What is the situation? Are we putting things together? Are we taking things apart? And then it says, will our answers be greater than or less than? That's really a check for reasonableness. So now I'm going from understand and I'm popping down here to checking for reasonableness. It doesn't have to be linear. Because I'm asking them, okay, so before we solve this, now you know that we're sharing equally. What number would be too high? If we got this answer, we know that's unreasonable. It's not possible. And someone said, well, 295. Like, why would 295 be unreasonable? Well, because we're looking for the number of buses and there's 295 students. So if I said there's 295 buses, then maybe there would be a kid on every bus. That would be unreasonable. I'm like, you're right. So too high would be 295. What else? And someone's saying, well, I know there's 25 on every bus. And I know that there's 4 25s and 100. So 4, 8, 12. If I had 12 buses, that would be more than 295. That'd be 300. So 300 would be also, so 3 buses would also be too high. I'm like, oh, that's interesting or not 3 buses. I'm sorry. I said that wrong. Or 8, 12. 12 buses would be too much, right? So they're starting to think reasonably about what they know about the number, its size, and then conversely, what's too small. What number would be too small? And they're like, well, 2 would for sure be too small. Why? Well, that's only 50 kids. There's 300. Okay, what else would be so they're starting to think reasonably. They're using mental math. It doesn't mean I don't need an answer. I don't even need them to be right with their estimate. I just need them to have a ballpark figure. So when we finally solve the problem, they're like, oh, yeah, I'm pretty close actually to our guess, right? So that means it could be a number line And I say, so this would be too low, this would be too high, it has to fall in here. So what are you estimating the number is going to be? They put an X on the number line about where they estimate. And then when they finally solve, they come back to see what were we close? How good was our estimation? So now we go to represent. Okay, so we've talked about what we kind of already know about the largeness or smallness of that number. Represent means what is the model that tells the story? Okay, so this is not new to math expressions. This is not new to everyday math, to Envision, to whatever curriculum you're using. This is in the standards. It's in the learning progression language. So there are 6 situations, and every single situation, at least in the curriculums I've worked with in the past, have some sort of a model that can be used to model that situation. So it's either an add to, take from. Okay, I have some apples, I add to them. I have some apples, I take from them. That's an add to, take from. And generally, we just use an addition or subtraction equation for that. And that's how we represent it. We can tell the story with the equation. But then we also could do maybe circle drawings in the younger grades. There's some other ways we can model that problem. Same thing here for put together, take apart. But this is a different type of problem. Instead of I had some apples and I took some, or I had some apples and I add 2, now we're putting together and taking apart. So put together, take apart is more of, I had some apples. Some were green, some were red. I didn't get more apples. I didn't lose apples. I'm not comparing apples. I just had some apples and I broke them into 2 groups. That's a break apart problem. We're using this number bond, part total, the math mountain, depends on what curriculum you're using as to what you call it. This is the model we draw to tell the story. Okay, if it's additive comparison, that is a comparison bar, or some curriculums call it a tape diagram, right? I'm comparing. Johnny had 7 cupcakes. Sarah had 3 cupcakes. How many more did Johnny have? That's not how many more as in add them together. They didn't get more cupcakes. It's not subtracting. Cupcakes weren't eaten. It's not about the operation. In fact, no one's allowed to say, let them say the operation. Tell me the situation. This is a comparison problem. I didn't get more. I didn't eat any. I'm just comparing. Who has more? Who has less? How are they different? Is it equal groups? I have the same number over and over and over. Now you can see where the grades are that are responsible for these particular problem types. And the grades that everything that happens like before grade 3 is also responsible for, in addition to all these new ones that grade 3 has to do. So equal groups, area, and array. They also do equal shares, which is our division. Multiplicative comparisons. This is in 4th grade. So it's like the comparison bar, but now we're saying it is 4 times as big as Johnny. It is in 5th grade, then we'll say it's 1/4 that of Johnny. So all of these types of problems have a model. So when I go here and I represent, I'm representing, in this particular case, I would probably represent with an equal shares drawing. I would draw a circle that says 295, and then I would say draw a 1 stick out and it says 25. So I know that if I shared in one group, 1 bus, get 25. I draw another leg out, draw another circle, another 25. I've shared 50. I would show the model. I wouldn't even maybe finish the model. I'm not doing the math yet. I'm just saying I recognize, and I want you to know as my teacher, that I know this is an equal shares problem. And then I would draw an unknown box or a variable for what we don't know. And we don't know how many of those circles at the bottom we're going to get. We don't know how many buses are going to be. So I don't solve it because I want an unknown box or variable to tell me what we are solving for. We use the model now to go back down here to solve. Okay, so if I'm coming over here to solve, now I say, oh, I see 25, 25. So really, we're just taking 295 and we're going to divide it by 25. Great. Come down here. This is where you use your various strategies. Long division, inverse operation, use multiplication. This is when you could do repeated addition to solve this problem, right? I don't care. So now you choose the operation. What does the model tell you is the operation? This is the situation. This is the operation. And I could add, I could multiply, and I could divide to follow this answer. So we have to stop saying, what operation should we do? I don't know. You decide, right? I could argue all of them. Finally, once we get an answer, we go back and we check for reasonableness. We say, was our answer reasonable? Is it reasonable that I got 100 buses? That something should trigger in my head. That is not reasonable. That's also building solid number sense. So remember that there's the 6 situations as you go through the entire problem solving process. So this graphic organizer you're going to have here down below, you can attach to download that. This is meant for maybe putting a story problem here. So oftentimes people will cut out the story problems from workbooks. They'll put this in a plastic sleeve and then they'll like tape or glue or just set on top a story problem in the middle that students now have to go through the process with. All right, my friends. So now that we're here, let me take us off. Looks like we're stuck. Let's get where we're unstuck. All right. So remember that you can connect with me here. So I'd love to connect with you online, Facebook, Instagram. You can comment and let me know how this little tiny workshop was after you give it a try. Remember, there's 4 steps to the understanding process. Understand the situation, read it 3 times, retell and act it out. Then step 2, represent what is the situation with the correct model. Number 3, I want you to solve the problem. And number 4, we're continually checking for reasonableness. Cubes could come in last. Cubes could come in during the solve, or cubes could come in during the check for reasonableness, because now I'm going to make sure like you solve, but look, you didn't even use the right numbers. That's when cubes is helpful, right? Because some kids are not even taking the information correctly once they figured out the problem. So then maybe cubes comes in to make sure that we really have done due diligence with all of the skills involved in reading that particular story problem. All right, friends, be well, and we'll see you online. Remember, tons of courses are on my site, www.empowerlearngrow.com. Courses on partner talk and small group instruction, and you name it, and it's there. I hope to see you online. Take care.